Imagine a scale so small that it defines the limit of space itself. Welcome to the world of the Planck length, measured at an astounding 1.6 times 20's 90's 20's 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 20's, 35 meters. The Planck length is not just a number, but the smallest possible measurable unit in quantum mechanics. It's derived from key constants of nature, the speed of light, gravity, and Planck's constant. To put this into 1.6 times 20's of 20's 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 26 times perspective, if a proton was the size of Earth, the Planck length would be about as big as a proton itself. This illustrates just how minuscule it is. The concept was introduced by Max Planck at the end of the 19th century and has since become a cornerstone in theoretical physics, especially when discussing quantum gravity. Despite its small size, the Planck length is crucial for understanding the fabric of space-time. At this scale, classical physics breaks down and quantum effects dominate. Scientists use the Planck length to explore what happens at the smallest scales, where matter, energy, and space are all interconnected in ways we're still trying to understand. The Planck length is a fundamental unit that bridges the gap between quantum mechanics and general relativity, making it crucial for any theory of everything in physics. So there you have it, from subatomic particles to the vastness of space, the Planck length plays a critical role. What do you think about this fundamental measurement?